Data has become the lifeblood of our society, fueling our industries, our commerce, our healthcare, and nearly every other aspect of our daily lives. And the rate at which data is being produced is spiraling, more than doubling every 2 years. Retaining at least portions of this data for the long term is vital for both patient care and legislative conformance. Can you guarantee that in 10, 20, 30, or even 50 years from now, your organization's vital data will be accessible when you need it? Will your data be securely preserved in a financially viable manner? Welcome to a demo of Ensure, a 3-year European Union FP7 sponsored project in long-term digital preservation. Ensure is built on top of 4 main areas of innovation. Cost and quality models are being created to help dynamically configure a preservation solution with the price to performance value meeting business requirements. A lifecycle management engine controls the execution of business-defined preservation workflows. Cutting-edge ICT technologies, such as cloud computing and virtualization, are used to create scalable and financially viable solutions for long-term digital preservation. Data is secured over time, even in the face of new and changing regulations, users, and user roles. Ensure is validating its technologies on 3 real-world use cases from partner organizations from the worlds of healthcare, clinical studies, and finance. We will now look at a typical Ensure workflow for securing stored data and guaranteeing its integrity over time. We start by configuring the system through an optimization of business rules. We then ingest digital data to the system. Based on pre-configured business rules, the lifecycle management will run periodic fixity checks to guarantee integrity and may perform transformations on data as formats grow outdated. All actions are non-repudiably logged in an audit file. Search and extraction is securely done on the data in accordance with defined access rules. Saving data, however, is just one aspect of digital preservation. Applications that are used for displaying and interpreting today's data may no longer exist in the future when required. In Ensure, applications are captured as virtual applications and stored by Ensure's underlying preservation cloud, PDS. When data associated with a virtualized application needs to be accessed, a request is sent to PDS, which locates the stored application in a storage cloud, instantiates it in a compute cloud with the retrieved data, and gives the user access to the running application. We will now show how an Ensure system can be used in a healthcare environment, both to manage data over its life cycle and to execute a storelet for efficient extraction of an area of interest from digital pathology slices. To initiate Ensure, a system administrator configures the business requirements for each type of data and defines the storelets that run on the data. We'll see an example of storelets in action later in this video. To reduce the complexity of configuration, the administrator can select a predefined service level or SLA for each type of data. These levels of gold, silver, and bronze will have implications on both the cost and quality of the solution, influencing such parameters as the reliability level of the storage used, the number of times that data will be replicated for disaster recovery, and the frequency of the integrity checks to be run on the data. For example, critical patient images might be stored at the gold level, whereas information pages, which are of far less business and legal importance, can be stored only at the bronze level to save money. The retention period specifies the minimal amount of time that data is required to be preserved as is by the system. Based on weighing the economic value of the data against its preservation cost, the system may recommend deletion of the data at any time after this retention period. Data can be stored either on a public cloud or a private cloud. If stored on a public cloud, its placement can be restricted to exclude given countries or regions. For example, data can be prevented from leaving country or EU borders. Data encryption can be automatically applied to all data when it is brought into Ensure and automatically decrypted on retrieval. The configuration guidelines can now be submitted to Ensure for optimization and configuration proposals. Behind the scenes, Ensure uses files generated in the XML standard to communicate between its various configuration and optimization components. The technical configuration of the selected solution can also be viewed graphically. Within this view, you can see all relevant information for each of the data types in the system, including the storage backends to be used, the encryption policy, and the frequency of integrity checks. Once a preservation solution has been selected, with the click of a button, the system administrator can deploy the created preservation plan. The Ensure system is now ready to start preserving data. In addition to its ability to preserve data, another powerful feature of Ensure is its ability to receive executable modules called storelets, and then execute them close to where the data resides. Examples of storelets include analytics, image analysis, and integrity checking. This animation shows the power of storelets illustrated through an example from the world of digital pathology. Typically, multiple slices of a tissue to be examined are taken, stained with different dyes, and then captured digitally in DICOM format. The pathologist examines a given image and marks areas of interest upon it. Since the storelet is only returning the area of interest, images are returned faster and with lower network consumption than had the original images been returned. For more information about Ensure, visit our website at www.ensure-fp7.eu.